Module 2, Lesson 3. Our objective is to express metric capacity measurements in terms of a smaller unit. Model and solve addition and subtraction word problems involving metric capacity. So you're going to be converting liters to milliliters in this lesson. So liters is the volume or capacity an object has to contain a liquid. So 1 milliliter is a science beaker. So think of a science beaker, is 1,000 milliliters of liquid will fill this beaker. So 1 milliliter is going to be way down here at the bottom. And if I take 1,000 of them, they will fill up to this line right up here. You can think of 1 liter as being a water bottle. Most water bottles come in 1 liter measurements. So here's your liters to milliliters table. So for every 1 liter, you will have 1,000 milliliters. 2 liters, 2,000 milliliters. You will have 2 tables that look like this that will help you to have that conversion of liters to milliliters or milliliters to liters. Convert milliliters to liters. Remember, to convert means to rename. So I have 1 liter, 500 milliliters, which equals 1,500 milliliters. Converting liters to milliliters, if I have 5 liters, 30 milliliters, I'm going to convert my 5 liters to 5,000 milliliters. Then I'm going to add my 30 milliliters for a total of 5,030 milliliters. When converting milliliters to mixed units of liters and milliliters, if I start with 2,200 milliliters, it's going to equal 2 liters, 200 milliliters. If I start with 3,305 milliliters, I will have 3 liters, 305 milliliters. So I've given this chart just to kind of show what it looks like in picture form. So each beaker, think of them having different amounts of water in them. So where I have the line and the arrow shows where each beaker is filled to with water. So the first beaker shows where 1 liter would be, which equals 1,000 milliliters. In the second picture, I have 1 beaker is filled to the liter line right here, and the second beaker is only filled to the 400 milliliter. Together, they would equal 1,400 milliliters or 1 liter, 400 milliliters. The same with each of them. So looking to see where the line starts, that is always going to be the 1 liter line or 1,000 milliliters on each of our top ones. And then the additional milliliters shows it progressively going up in size, starting with 1 liter, 1,400 milliliters, 1,750 milliliters, 2 liters, 2,300 milliliters. This will come back in lesson 4 when you're comparing milliliters to liters and putting them from least to greatest or greatest to least. Adding mixed units of capacity using an algorithm or simplifying strategies. So 32 liters, 420 milliliters, added to 13 liters, 585 milliliters. First, I would convert all to milliliters. So 32,420 milliliters, added to 13,585 milliliters for a total of 46,005 milliliters. I could also just add my liters of capacity. So 32 liters plus 13 liters is 45 liters. Adding my milliliters together, 420 milliliters plus 585 milliliters is 1,005 milliliters. Again, this needs to be converted so that I can add all my liters together. So 1,005 milliliters is 1 liter, 5 milliliters. 45 liters plus 1 liter plus 5 milliliters is 46 liters, 5 milliliters. I can also use the algorithm as a strategy, making sure that I line up my milliliters and my liters, adding place value, ones, tens, hundreds, thousands, and 10,000s. I can convert all to milliliters and add. I can use separate units, so adding just my liters together, then my milliliters, then converting in the end. And again, you have an embedded video to show how to solve each. Now, notice that I might be showing a different unit of measurement in the video, but it's the same process for each of our units of measurement. Just because the measurement has changed unit-wise does not change the strategy on how to complete an addition algorithm or a subtraction algorithm. So when subtracting mixed units of capacity using an algorithm or simplifying strategy, again, you can convert all of my liters and milliliters to just milliliters. So 12 liters, 215 milliliters is equal to 12,215 milliliters. 8 liters, 600 milliliters is equal to 8,600 milliliters. Subtracting the two for a total of 3,615 milliliters, finding that difference between. I could also subtract using liters first, then bring in my milliliters. So 12 liters minus 8 liters is 4 liters. I'm going to convert my 4 liters to 4,000 milliliters. I'm going to add my 4,000 milliliters to the 215 milliliters, 4,215 milliliters, then subtracting off the 600 milliliters. So 4,215 milliliters minus 600 milliliters is equal to 3,615 milliliters. Again, converting in the end so that I have 3 liters, 615 milliliters. An algorithm can also be used for this strategy. So I've set it up so you can see all of my milliliters line up, my liters line up. I can convert everything to milliliters and subtract. Again, I can focus just on specifically liters first, then subtract off my milliliters. Again, I have embedded a video. Here's your note. It does not matter the unit of measurement you are working with. You will subtract with the same strategy. Only the unit label will change. So instead of it being kilometers to meters, it's going to be kilograms to grams or liters to milliliters. The strategy stays the same. Solving a word problem involving mixed units of capacity using the algorithm or simplifying strategies. So in this one, Jennifer is making 2,170 milliliters of her favorite drink that combines iced tea and lemonade. If she puts in 1 liter, 300 milliliters of iced tea, how much lemonade does she need? So what do we already know, setting up our foursquare, is that she's mixing iced tea and lemonade. We know that her total drink has to have 2,170 milliliters. We know that she's already put in her iced tea, which equals 1 liter, 300 milliliters. And we know that 1,000 milliliters is equal to 1 liter. I'm going to find the difference. So I could subtract or I could add up after I've converted all to milliliters. So that's what I'm going to choose to do on this one. I'm going to, instead of using the subtraction strategy, I'm going to use my adding up to my total. So the first thing I'm going to do is convert what her iced tea equals. So 1 liter, 300 milliliters is equal to 1,300 milliliters. 1,300 milliliters, if I add 700 more milliliters, that gets me to 2,000 milliliters. Adding onto my 2,000 milliliters, another 170 milliliters to get to my total of what her drink needs to be, 2,170 milliliters. Then I'm going to take what did I add to my number of iced tea milliliters, 700 milliliters plus 170 milliliters equals 870 milliliters. I cannot convert this back to liters because I need 1,000 milliliters to equal 1 liter. Again, making sure I have my equations in for each step, my statement and reasoning. Jennifer needs 870 milliliters of lemonade in her mix. Again, I have embedded a video that shows how to set up a tape diagram, how to add up to find the difference. As opposed to subtraction. Subtraction will still work in this case. I'm just showing a different way to solve this particular problem.